Alrighty guys, now it is time for the fun stuff. We are now going to apply what we have learned to real world stuff. Okay, so like how can I actually use this in the real world? Okay, so that's what we are going to be doing here. The first example we have, a rectangular garden is to be constructed using a rock wall as one side of the garden and wire fencing for the other three sides. If they have 100 feet, determine the dimensions that would create a garden of maximum area. And then I want to know what would that area be. So first off, let's draw this and see if we can make it make a little bit more sense, okay? So first things first is we have a rock wall. So there's a rock wall here. This is rock. So I do not need a fence on that side, okay? But the other three sides, I'm going to have fencing right here, fencing right here, and fencing right here. And the only thing I know is that those three sides are going to add up to 100 feet. So what I'm going to do is I'm going to just let one of these sides be the x, be x. And I want to see if I can write every other side in terms of that x. Well, as I can see, this side on top and this side right here are the same. So this one would also be x. And since the total is 100 feet, I know all three sides have to add up to 100. So if I have 100 feet for the total and I've already used x twice, this last side would be 100 minus 2x. Again, because I have 100 total and I've already used x twice. So 100 minus 2x. So this is what I want to deal with, okay? So now what it asks for is the maximum. Well, as we have seen, we know that the maximum is where I switch from increasing to decreasing, right? That's where the maximum is. The maximum is right here. So what I want to do is I want an equation for the area, and then I want to find the critical points, and I want to know which one of those points would give me the maximum. So first things first, I know the area of a rectangle is equal to the length times the width. So in this case, the area is equal to, I can let the length be this x, and so the width would be 100 minus 2x. Distribute the x, and we get 100x minus 2x squared. And if you are like me, I like to have the x squared term as the first term. So we can write the area is equal to negative 2x squared plus 100x. So now, again, how I can tell where I switch from going up to going down is I can find the critical points. As we have seen, we do that by taking the derivative and setting it equal to 0. The derivative of this, I can bring my 2 down, so that would make it negative 4x plus 100. And then we're going to set that equal to 0. Solving that for x, we can add 4x on both sides just to make everything positive. So 100 equals 4x, divide by 4, and we get 25 is equal to x. So if x is equal to 25, I can get this side length by plugging it in. So 100 minus 2 times 25, that's 100 minus 50, so this side should be 50. So what this means is how I get the maximum area is if I have the dimensions would be 25, this is in feet, so 25 feet by 50 feet. Now I want to know what would that area be. So there are actually two ways I can do this. The first way is I know a of x is equal to this stuff. So if I know x should be 25, I can just plug 25 in. So that would be negative 2 times 25 squared plus 100 times 25. 25 squared is 625. 100 times 25 is 2500. 625 times negative 2 is, I was going to try to do that in my head, but that's not going to work. 625 times 2, carry the 1, 1250, so negative 1250 plus 2500, which will give you 1250 square feet. Now, an actually easier way is like we wrote down over here, area is equal to length times the width. So we can just do my length 25 times our width 50, which would also give you 2550. Either way works, they're both right. So again here, the maximum is going to be my critical point. Now this one worked out really nicely because I only found 1 point for x, right? But what if we found more than 1, right? To make sure I have the maximum, what I should really do is put the number line. My critical point is 25, so I need a test point to the left. Let's just use 24. Test point to the right, let's use 26. And I should plug these into a prime. So a prime of 24 would be negative 4 times 24 plus 100. Negative 4 times 24 is negative 96. So negative 96 plus 100, which gives you positive 4. So I'm increasing over here. Then do the same thing for 26. Negative 4 times 26 plus 100. 26 times negative 4 should give you negative 104 plus 100, which is negative 4. So it's decreasing over here. So that's how I can prove this is the maximum, is because I'm switching from going up to down. But since I only found 1 point here, we knew it must have been that point. So we're good there. All right, another example that I really like. An open top box is to be made from a 24-inch by 36-inch piece of cardboard by removing a square from each corner. And then I'm going to fold it up. What size square should be cut in order to maximize the volume? So conceptualizing this might be hard, but basically what I do, we have a rectangular piece of cardboard, and it says it's 24 inches by 36. And what I'm going to do is I'm going to cut a square from each corner, which will then allow me to fold everything up. So what I want to do, they want to know what size this square should be, so I'm going to let this be x. So it's going to be x for all of them. Okay, so now they want to know what the maximum volume is, right? So remember, the volume of a rectangular prism is just the length times the width times that height. So what I need here is to know what the length, width, and height are, okay? Well, the length of the total side over here is 36, right? But I'm cutting off x right here and x right here. So the length is actually 36 minus 2x. Again, because I'm starting with 36, I'm going to chop off x and x, so 36 minus 2x. Again, for the width, I started with 24, but I'm going to chop off x and x, so it's going to be 24 minus 2x. Then my height, if I fold everything up, you can see my height is going to just be this x. So my height is x. So let's distribute this to simplify it. Let's do 36 minus 2x times 24 minus 2x. 36 times 24 is 864. 36 times negative 2x is negative 72x. Negative 2x times 24 is negative 48x. Negative 2x times negative 2x is positive 4x squared. And I'm going to have all of that times this x out here. Combine like terms, and you have 864. Negative 72 minus 48 is negative 120x plus 4x squared. All of that times x. So distribute the x now, and you get 864x minus 120x squared plus 4x cubed. Again, I like having the highest term at the front, So I want to move this cube term up front. And there we go. So again, I want to find the maximum, which means I need a critical point. So I need to take the derivative of this. The derivative of v, bring the 3 down, that's going to be 12x squared. Bring the 2 down, minus 240x. That's going to be just 864. And you can set that equal to 0. I believe all of these are divisible by 12. Yes, so since all of these are divisible by 12, let's just divide it by 12. 12x squared over 12 is just 1x squared. Negative 240x over 12 is negative 20. Sorry, I've been doing a lot of math, so mental math right now is impossible. Yeah, negative 20x. 864 over 12 is 72. Equals 0. So to solve this, I just need to find the factors of 72, whose sum is equal to negative 20. That should be, let's see, let me try 72, that would be 36 times 2. That doesn't work. 72 divided by 3, 24 and 3, that doesn't work. What about 4? To do 4, we would do 4 times 18. That doesn't work. 5 doesn't work. 6 and 12, that also doesn't work. Therefore, this cannot be factored. So I need to solve this another way, because there's no factors of 72 whose sum is equal to negative 20. So I need to solve this some other way. There's a lot of ways to. The way that I really like is by completing the square. How I do that is I bring my constant over to the right side. X squared minus 20x plus, and the whole point is I want to add my own third term to make this a perfect square. So to add that third term, what I really want to do is I want to make this a perfect square, right? That's the whole point. To find what's in here, I divide the middle term by 2. So that's going to be x minus 10 squared is what I want. But in order for it to be that, I need to find out what this third term is. Well, to find that, I would just do 10 squared. 10 squared is 100. But if I want 100 over here, I have to also add 100 on the right side. Negative 72 plus 100 is 28. So now to solve this, we take the square root on both sides. So x minus 10 equals plus or minus. Let's figure out how to write the square root of 28. Well, 28 has a factor of 4. So that's square root of 4 times 7. And the square root of 4 is 2. So 2 square roots of 7. And then I want to just add 10. So x equals 10 plus or minus 2 square roots of 7. All right. So I have found two things x could possibly be. 10 plus 2 square roots of 7, or it could be 10 minus. To help us out, let's see what the numerical value of those are. So if I did 10 plus 2 square roots of 7, I get about 15.3. If I do 10 minus that, so 10 minus 2 square roots of 7, that's going to be about 4.7. So let's think about which one of these could possibly be the right one, okay? So remember, the whole point, what I want to do is I'm taking off this much, right? If I chopped off 15.3 from each corner, notice what would happen here. I would chop off 15.3 from right here, 15.3 right here, which means I'm doing a total of 30.6 from this side. However, this side only has 24 there. So it doesn't make sense for it to be 15.3 because it would be too much here. So this one is not right. So it must be 10 minus 2 square roots of 7. So the amount I want to chop off is 10 minus 2 square roots of 7 inches. Again, we need to check and make sure that makes sense, right? If it was 15.3, I would have too much off of here. All right, this next example is another one I really like. An island is 2 miles due north of the closest point along a straight shoreline. So let's go ahead and draw this. I have a shoreline, and I have an island out here, and we're saying this island is 2 miles from the north. So 2. I know that much. All right, this is the island. A visitor is staying at a cabin on the shore that is 6 miles west of that point. I should have drawn more land over here. It doesn't really matter. For the sake of this, I'm going to draw it over here. But like I said, it doesn't really change anything. This is my cabin. And we know it is 6 miles for this whole thing. This whole thing is 6. The visitor is planning to go from the cabin to the island. Suppose the visitor runs at a rate of 8 miles per hour and swims at a rate of 3. How far should the visitor run along the shore before hopping in and swimming there? So basically what this means is he's going to run a little bit, and then at some point he's going to hop off and he's going to swim the rest. I want to know how far should he run. So I'm going to let this length right here be x, and therefore this length right here is the total 6 minus that x. So to figure out what this side length is over here, we use the Pythagorean Theorem. 2 squared plus 6 minus x squared is equal that side length squared. I'll just say c. So that's 4 plus 6 minus x squared. You would have to do 6 minus x times 6 minus x. 6 times 6 is 36 minus 6x minus 6x plus x squared. 36 minus 12x plus x squared. So that's going to be plus 36 minus 12x plus x squared. Combine like terms, 4 plus 36 is 40. And so if I want the side length, I take the square root of that. So this side over here, okay, I'm actually going to change it up just a little bit because it's going to help us out if we leave this as 6 minus x squared. So ignore all of this, pretend I didn't do any of this. We're going to leave it just like this, and you will see why here soon. So like I said, this is going to be 4 plus 6 minus x squared. The square root of all that. The squared should be on the outside. Okay, so they want to minimize time. So I need to use all of these words to find a function of time. Okay. Well, I know his speed to run is 8 miles. So he can run 8 miles in 1 hour. That's his speed. Now remember, speed is equal to the distance divided by my time. So if I want an equation for time, I could multiply by time, which would cancel it out, and then divide by my speed. So how I can get my time is I can do my distance divided by my speed. So on the land, okay, on the land right here, I'm going to write my t of x. On land, how far I run is this x. So on top, it's going to be x. Divided by my speed, I know my speed on the land is 8. So x over 8. That's my time on the land right here. But then I'm going to hop out and I'm going to swim over here. So how far I've got to swim is this square root of 4 plus 6 minus x squared over my speed to swim, which is 3. So my t of x is all of this. Again, it's time, and time is how far I've got to go divided by my speed. So to figure out how to minimize that, again, I need my critical points. So I do that by taking the derivative. X divided by 8, that's like saying 1/8 x, so that's going to be 1/8, plus the derivative of all of this is going to be a little bit more work, but it still isn't bad. So first of all, we have a constant of 1/3, so let's just leave that. We know whenever I have a square root, it's going to be 1/2 times that square root. But because of the chain rule, I also need the derivative of the inside stuff, right? The derivative of 6 minus x squared, I need the chain rule there too. Bring the 2 down. Then the derivative of 6 minus x is -1. So I can just make that -2 right here. And I need to set that equal to 0. First thing I see is the 2's cancel out right here. That's kind of helpful. So if I set that equal to 0, I can just move this 1/8 over to that side. 1/3 times 6 minus x, so let me put the 6 minus x on top, over 3 square roots of 4 plus 6 minus x squared equals -1/8. So now I can cross multiply 8, dang it, times 6 minus x equals -1 times all of that stuff. So -3 square roots of 4 plus 6 minus x squared. I need to solve this for x. I have a square root, so let's square both sides to get rid of that square root. 8 times 6 minus x squared. 8 squared is 64. And then I can just leave that as 6 minus x squared equals -3 squared is 9. And then I have a square root squared, so they just cancel out. Over here, distribute this 9. We have 64 times 6 minus x squared equals 9 times 4 is 36, plus 9 times 6 minus x squared. Now, the reason I said leave it just as this stuff squared is because now look, since I have 6 minus x squared over here and 6 minus x squared over here, I can just subtract it to bring it to the same side. Or sorry, minus 6 minus x squared. 64 minus 9 is 55. So that's going to be 55 times 6 minus x squared equals 36. Divide by 55. 6 minus x squared equals 36 over 55. Take the square root on both sides because it's squared. We have 6 minus x equals plus or minus the square root of 36 over 55. Subtract 6. Negative x equals -6 plus or minus square root of 36 over 55. Divide by the -1, and you get x equals 6 plus or minus the square root 36 over 55. So again, I have two values here, 6 plus the square root of 36 over 55, and 6 minus 6 over 55. But again, I need to see which one of these is actually the right one. Well, if x is equal to 6 plus more stuff, it doesn't really make sense, right? Because this entire side length is 6. So if it was 6 and then plus more stuff, I would be running past it, which doesn't really make sense, right? So instead, I'm going to use the minus. That's how far he should, run to minimize his time. If you put that into a calculator, you would see it's about 5.19. So he should run 5.19 and then hop out and swim. That one is really fun. I love that one a lot. This one is a great one. All right, two more. Owners of a car rental company have determined that if they charge the customers $P per day to rent a car, the number of cars N they rent per day can be modeled by N of P equals 1,000 minus 5P. If they charge $50 per day, they are going to rent all of their cars. And if they charge $200, they will not rent a single car. Assuming they plan to charge between $50 and $200, how much should they charge to maximize the revenue? So the first thing is to really know what this word means. This is how much we are going to make. How much we make. So what this means is I want to know how much I'm going to bring in, right? Well, what that's going to be, the revenue, is going to be equal to whatever the price is times the quantity I'm going to rent out. That's going to tell me how much I'm going to bring in, okay? So the price, we can just let price be P. So let's find the revenue in terms of P. My price is just P. The quantity, as we set up here, is N of P equals 1,000 minus 5P. So I can let that be the quantity. Distribute my P, and we see 1,000 P minus 5P squared. Again, I like having the square term up front. So I'm going to do negative 5P squared plus 1,000 P. So once again, I need to find the critical points. I do that by setting that equal to 0. Both of these have a factor of negative 5P, so let's factor that out. And so I'm left with P minus 200 equals 0. So then we're going to set each factor equal to 0. So divide by the negative 5, P equals 0 here. Add the 200, P equals 200 here. Well, as we said, we want it to be between 50 and 200, right? So what I want to know is how much I should do between that, right? Alrighty, guys, so sorry about that. I paused it because I realized I skipped a huge step. To find the critical points, we have to take the derivative. So we got to take the derivative first. I skipped that really big step. If that's R of P, the derivative would be, bring the 2 down, negative 10P plus 1,000. Set that equal. That makes way more sense. I looked at this and I was like, I messed up. I don't know where I messed up. There it is. Okay, we've got to take R prime first. So to solve that, we can just add 10P. 1,000 equals 10P. Divide by 10, and you get 100. So this means my price should be $100. That's how I'm going to maximize how much I'm going to make. Sorry for the mix-up there. All right, we have one more example. A rectangular box with a square base, an open top, and a volume of 216 cubic inches is to be constructed. What should the dimensions be to minimize the surface area? All right, so first things first, we have to remember it talks about the volume. So we know volume is equal to length times width times height. I know the volume is equal to 216. It also says my base is square. So since my base is square, this means my length and my width are the same thing. So for width, I can just replace that with length, which would make this length squared times h. Now the reason this is good is because now I know my height. If I just divide by length squared, I know my height is equal to 216 over length squared. Now, why is that good? Because we know surface area is the sum of every side. Okay, so we have a square base, so the area for that side is going to be my length squared, but there's no top, and so I just do that the one time. My next side is going to be whatever my length times my height is. But remember, it's a square base, which means all 4 of the sides on the outside are going to be the same thing because it's a square base. So all 4 of them are going to be my length times my height. Again, because it's a square base. The reason this is good is because we know my height is equal to 216 over L squared. So I can plug this in for the height. L squared plus 4L times 216 over L squared. 4 times 216 is 864, so this is L squared. And then L over L squared is going to give me over L. So 864 over L. So to figure out what the minimum is, I need to find the critical points. So we're going to take the derivative of that. The derivative of L squared is going to be 2L. The derivative of 864 over L, it might help if you write it as L to the negative 1. Bring the power down, so negative 8. Okay guys, I'm back. I had to pause it this time because my computer ran out of storage, and so I had to wait for the last one to be completely done, and then I could do the rest of this one. So I am back. Okay, so what we have done is we just did SA prime, and so now I have to set that equal to 0 and solve it for L. So we're going to add 864 over L squared to both sides. I can multiply both sides by L squared to cancel it out over here. So that gives me 2L to the third equals 864. Divide that by 2, and we get L to the third equals, whenever I do 864 over 2, we get 432. So to get L, just take the cube root of it. So L is equal to the cube root of 432. So I know that's my length. And so now I know, because we know that it's a square base, we know that the width and the length are the same thing. And so since that's my length, I'm just going to rewrite it over here. And this is in inches. My width must be the same thing because it's a square base. And then I know my height is equal to 216 divided by L squared. So that's going to be the cube root of 432 squared. So let's just write it as 432 to the power of 2/3. And here we go. So basically, in all of these, what I want to do is I want to find the critical points. That's what I'm trying to do. Alrighty guys, if that does not make sense, please let me know and I will be happy to help you out.